Hello, for this week's module or discussion 5, I got a sample from the current Galoot sample that we were required to do, and this is my first sample that I drew. And as you can see on the left side, I have my descriptive statistics, and the sample size that I decided to draw was 10. And so over here in the table, you can see my proportion as 0.30 or 30%. And then if we go over to the bar graph, the 0 in this bar graph means that no, they did not care for offspring, and the 1 is yes, they did care for offspring. And then up here I put my standard error as 0.145, but I have a different sheet that I will show you later of all my calculations I did for the 3 samples. So from here I will go to my second sample. And again, I did, the sample size is 10. And for this one, the proportion was 0.40 or 40%. And so kind of interpreting the bar graph, you can see that 60% said no to caring for offspring, and then 40%, which is our proportion size, do care for offspring. And the proportion is the statistic that we are interested in for this discussion, and this can be used as an estimate of the proportion of galoots on the whole planet caring for offspring. And then from here, so my standard error for this one is 0.155, and then for my third sample, again, sample size is 10, and my proportion is 0.20 or 20%. So for the bar graph, 80% said no to caring for offsprings, and only 20% said yes to caring for offsprings. And then my standard error for this one is 0.126. So now I'll go and show you all my calculations that I made. So for sample 1, I got P as 0.30, and then for Q, I subtracted 1 by the proportion and got 0.70, and then the standard deviation we already knew from the descriptive statistics, and that was 0.46. And then for my standard error, I just took the square root of P times Q divided by 10 and got 0.145. And then for my lower limit and upper limit, I got negative 0.241 and 0.328. And I will show you that later on the number line once I get to it. And then for sample 2, again, just did the same steps. So the standard error was 0.155, and then the lower limit was negative 0.242, upper limit was 0.366, and sample 3, standard error was 0.126, lower limit was negative 0.221, upper limit was 0.272. And then in regards to was the sample large enough to satisfy the success failure condition? None of my samples met the success failure condition because they were all under 10. So for sample number 1, 10 times the proportion was 3, and then 10 times Q, or 0.7, was 7. So it did not meet the success or failure condition. And same with sample number 2. I got the proportion times the sample size as 4, and then sample size times Q as 6. So again, they did not meet the success failure condition. And then for number 3, I got 10 times P, or 10 times 0.2 as 2, and 10 times 0.80 as 8. So again, no, they did not meet the success and failure condition. So from here, we will move on to the line, or the number lines that I came up with. And I guess kind of interpreting the success failure condition one more time. This condition encourages a large sample size, and obviously a sample size of 10 isn't big enough, and since they aren't met, or since the numbers didn't meet the success failure condition, the book in chapter 13 says we can use the normal model to model the sampling distribution of the sample proportion. So yeah, we'll just take that information and kind of interpret that. So as you can see, this is my sample 1. sample 2, and sample 3. And they're similar in the way that they all have a 95% confidence interval, which we can say for all three of these that we are 95% confident that the true proportion lies in between our interval. So basically saying that our confidence lies 95, we're 95% confident that our proportion lies in between these two bars. And I just kind of wanted to move the box up so you could see the lines better of where I graphed these numbers. And then the results were different due to being random and independent samples. So since we did draw like different samples, the results are obviously going to be different. And these samples are not dependent on each other and therefore have no relation to one another. And then kind of like reflecting on if I thought these would be different or similar, I thought the results would be different. I mean, I know I took a small sample size, and I figured they would be close in number just based on the calculations and everything, but I was kind of surprised to see that they were as close to in numbers as they were. But other than that, that is my discussion 5. Thank you.